Welcome everyone to this edition of the Blockchain Blueprint. I am joined today with Piers Ridyard, and according to their website of Radix, he is the CEO there, and he personally started in blockchain by experimenting with insurance smart contracts in 2015. He was also involved with helping create the world's first decentralized data room. As for Radix themselves, they are a speedy, scalable alternative to blockchains and DAGs. Their mission is to provide developers with the best tools to build and deploy decentralized applications, tokens, and coins. So without further ado, let's get into it. Can you give a bit of background into yourself, if that's cool, Piers?
Sure, absolutely. So I first got into crypto in sort of the very start of 2015, when a friend of mine said, have you heard of this thing called Ethereum? They're doing a crowd sale. And I was like, no. He was like, well, let's try mining it when it goes live. And so we started mining Ethereum, and that was like my first intro into the world of DLT and blockchain. And it was from there that the first sort of like blue sky thinking started to evolve, with things like the concepts of decentralized autonomous organizations and what a smart contract could do, and what new businesses that could emerge out of the existence of a smart contract, and how they would fundamentally differ from sort of existing enterprises, and what tokenization meant and how you can tokenize things. And so a lot of this drew from a number of the different things that I've done before this, like before I was in crypto, I was building consumer electronics. Before that, I was in investment banking and law. And so a lot of all of this sort of fed into both the fundamental components of the building blocks of how you actually run a mining operation, and how miners maintain a decentralized ledger, to sort of the legal and the financial ramifications around a fundamentally financial technology. So it's been a fascinating journey from then until now.
Fantastic. And so you mentioned you were in crypto before, and that's what led you into blockchain, I suppose. But why did you decide to enter into the blockchain space, as it were, rather than cryptos?
I did both. I don't really. When I say crypto and blockchain, I use them interchangeably. I don't differentiate between them. The blockchain being the enabling technology of cryptocurrencies, but cryptocurrencies, generally speaking, being the biggest manifestation of that technology. So even when you look at something, there are some exceptions to the rule, right? So like R3's Corda and IBM's Hyperledger, but the majority of sort of crypto and blockchain is in the tokens themselves, and the new funding method that enabled for people to suddenly start developing these platforms. I went in on everything. I love the technology. I love the economics. I love the sort of the new business models that were possible, and I love the community as well. There's like a really tight community, great startup and meetup community in London, and that was really vibrant and really excited and really passionate, and also like sort of very ambitious in what it wanted to do with this technology. So yeah, I wouldn't say that I differentiate between either. I just got involved with everything.
Sure. So let's get into Radix itself as a business model. What does that offer that any other data or any other platform does not? Because you pride yourself as being like the future of blockchain, but you're not blockchain at the same time. Is it Is it almost an evolution of blockchain, or is it just something else entirely?
It's an evolution of the concept of blockchain, but it's something else entirely. I mean, it's like any technology. Like, you can get a certain distance with a technology, and then you need to change what technology base you're using, because fundamentally that one can't be extended anymore. Blockchain is a data structure. You have a block of transactions that fit into a sort of a mined token validation, and then that then gets chained together by, with other blocks as they later come on. This block provides the seed for the next block, but it's sequential, right? So I create this block, and then when that block is created, I then have a period of time before the next block is going to be created, and I have a certain number of transactions I can fit into that block. And fundamentally, that as a concept doesn't scale. Reason being is that you have to share that block around all of the computers in the network. So you get this weird thing that as more nodes come online, the network actually slows down, becomes less capable of transacting, of processing throughput. And you have this upper scalability limit, which is the amount of time it takes for a block of data to move around the network, such that more than 51% of the node of the miners are synced up on the current block. And as soon as you get past that limit, then it all falls over. And so on an unsharded blockchain, that's like 500 transactions per second. And then as soon as you start trying to shard that blockchain, you suddenly get all of these other problems, which is like you massively reduce your security of the blockchain. If you say, okay, you nodes over there, you're going to do this 50% of it, and you nodes over there, you're going to do this 50% of it. You then have this coordination overhead, which is like, well, if I've got a transaction on this one, how do I get it across to this chain, and vice versa? So people talk about having these master chains and these sub chains, but the master chain has still only got that upper scalability limit of 500 transactions per second. So fundamentally, the whole thing is flawed as a way of building a scalable global infrastructure. So what we did as Radix is we said, look, let's not look at what's already been built. Let's take this concept of a DLT, of a decentralized ledger technology, of this idea that there should be the ability for truth to be an emergent property of a system, and that you can have a trustless infrastructure as a result of that. Let's take that idea and then say, well, what's our endpoint? What do we want to achieve? Where do we want to get to? And the endpoint is that you want every single person, every single device in the world to be able to use that infrastructure simultaneously, which is 7 billion people and 24 billion devices. And if you want an infrastructure that is capable of 7 billion people and 24 billion devices simultaneously using it, then you fundamentally need to rethink how you're building it. Because for a start, the difference between, for example, TCP/IP, like the internet protocol, and a DLT protocol is that for something to be trustless, it has to be stateful. It has to have memory. It has to remember what happened. Like if I send a transaction to you across a DLT, then the DLT then has to remember that that transaction has occurred so that you can then send that transaction on to someone else. And I can't re-spend that transaction, right? So I can't double spend. And that requires memory. That requires everyone in the network being able to validate if something is valid or invalid, given what's happened in the past. Yeah. And that gets even more complicated when you start looking at things like smart contracts, where smart contracts have multiple states, all of which that have to be kept updated and maintained. So you need to start with going, well, 7 billion people, 24 billion devices, all simultaneously using something. That's going to be the world's biggest database. That is going to fundamentally be bigger than anything that we've come across before needing to service the world, because suddenly we need to be able to validate the truth of anything that is done by anyone on that network. And that problem then starts with a database problem. It's going, well, how do you make a database big enough to be able to service that number of people? You need to do a few things. The first thing you need to do is you need to shard it, because no one computer can maintain that entire database. It has to be split up. But the problem I was talking about with blockchain is that you have this overhead problem of constantly talking to all these different blockchains and cross-validating. And that's a problem if you're dynamically sharding, if you're changing the shard space constantly, you're constantly having to tell everyone what the new shard space is, and you have no good way of predictably addressing that data. So instead of that, you don't dynamically shard it. You say, let's start with a shard space that will never have to change. So on Radix, we start with 18.4 quintillion shards, right, which is 2 to the power 64. And that is bigger than you will ever need for even at 7 billion people and 24 billion devices. We know this because we looked at Google and we said, okay, well, how much data is Google warehousing today? And the answer is about 10 exabytes of data. If you take 10 exabytes and you divide it by 18.4 quintillion, you come up with 4 bits per shard. So the Radix data structure could store everything that Google is storing and only end up with 4 bits of data requirement per shard, which is a tiny, tiny amount, meaning that even tiny computers can make up part of the Radix infrastructure without ever having a problem of not enough storage space or needing, needing greater processing power or something like that. So that was fundamentally the starting point. We threw away the data structure that made blockchain a thing, and we went, no, blockchain doesn't work as a data structure. We need to build something else. So we created the Radix data structure, which is called Tempo. And then the next thing we did is okay, now we have that, we need a way of making sure that transactions can be linearly scalable, right? So as more people join the network, instead of the number of transactions going down, like what happens with blockchain, it should go up. The more resources you have on the network, the more throughput the network should be capable of. So what we realized we could do once we had 18.4 quintillion shards was we realized that we could make the data structure deterministic. So we could say, okay, you have a public-private key pair, which is often referred to as a wallet, right? Now your public key, let's make your public key dictate which shard you live on. So we take your public key, which is a 256-bit number, and we modulate that down to a 64-bit number, which is a mathematical operator, very simple one, and anyone can do it, to an address. And that says, okay, Piers lives on shard 5. Now what that does is it means that it groups together related transactions and ungroups unrelated transactions. And the magic of that is I can spend 18.4 quintillion shards, but I can only spend from shard 5 because that's where my wallet lives. That's where it's determined to live by my wallet address. So if I'm going to double spend, the only place I can possibly double spend from is the shard that I live on, meaning that I don't have to now check and coordinate across 18.4 quintillion shards to make sure that I'm being honest. All I have to do is check the shard that is determined by my public key that all of my data lives on to make sure that my spend is a valid spend. And what that does is it makes the entire system incredibly efficient. Because if you live on shard 10 and I live on shard 5 and you send a transaction to your mother and I send a transaction to my mother, neither of those transactions have any relationship to each other because they don't live on the same shard and they're not going to the same addresses. So there's no need to exercise consensus versus each other. You just need to make sure that those are honest on that shard that the transaction leaves from and the shard that the transaction leaves from. So this makes the entire system incredibly efficient and capable of scaling to that 7 billion people and 24 billion devices, which no other infrastructure is capable of getting anywhere near. Most of the arguments that you're hearing at the moment is, okay, so we can do 10 transactions a second at the moment, so we've done this update and now we can do 100 transactions per second, or we've done this update and we now do 5,000, whatever it happens to be. But none of them have fundamentally gone, let's not talk about like moving around small chairs here. Let's talk about what the data structure needs to be for it to service the world.
Fantastic. With the numbers you were using in terms of quintillions and 2 to the power of 64 that you mentioned, these are numbers that you would equate with the processing power of supercomputers, perhaps, like, or equivalent to that. So it's quite interesting you use these sort of, grand scale things to, where there's like endless storage, because just, for all the talk of that, there's also people talking about cloud computing as well, which personally I feel needs blockchain involved. I don't know what you think about that.
That's a broad question. So on the 18.4 quintillion point, like these are not 18.4 quintillion things that exist. They're 18.4 quintillion things that could exist if they follow the numbering, the addressing format, right? So a great example of this is all of the telephone numbers that could exist in the world do not exist, right? Only the ones that have been claimed exist. The rest of them are available, but they don't exist yet. They're not already being managed by anyone. And so this 18.4 quintillion shard space is the same concept. Once you claim a telephone number, that now has an address within the system and is able to be managed by the system. But until someone creates a public-private key pair where the public key is determined to live on a shard that has never existed before, but is in that 18.4 quintillion shard range, and receives some funds, because it's not just creating the public-private key pair, I can do that all day, it's then receiving some funds, so it has to have a recording of it. That's the only time it has to appear. So actually, day one, the amount of data required to store the entire ledger is incredibly small. It grows as more people use it and as more of those shard spaces are filled. So it's a very, again, a very scalable way of doing things, much like the telephone number system. On the should cloud computing and DLT have some sort of overlap? I mean, there's plenty of projects that are trying to do that, and in some ways you can look at a DLT as a multi-purpose cloud computing infrastructure. Like, you have nodes that are running the software that maintains the network, and that network will have a some sort of state transfer machine that allows you to do computing of code, and that can be something, you know, like Ethereum's Solidity EVM, and that EVM can process, you know, anything that's Turing complete. So you can use a DLT or blockchain infrastructure as a form of cloud computing, but the problem is that it ends up being very expensive because you've got this high level of duplication and you've got this trustlessness aspect of it, and not everything that needs to be computed needs to be trustless. There's certain things that you don't need to be trustless. It's just like a CDN, a content delivery network, and it's not critical content, or you want to store some data but only you really want it, so you don't want to pay for it to be duplicated a million times across the world. So there's definitely going to be an overlapping of cloud computing utility, where like I need to do something, but it's not necessarily needed to be done on a DLT, and what a DLT provides. And I think they're going to come together very nicely because of this ability to do microtransactions and logic-based transactions and validity transactions on a DLT, and then the service element of being like, I only need a server to crunch these numbers for me and return the answer to me. I don't need every server that's running on the DLT to be doing that. I just need this server to do it, and I'm fine with just shopping that out and having it returned by, you know, a third party. So yeah, I think they're really interesting, and they'll come more and more together over time.
There seems to be an inevitability about that as well, I would think. And so when people use financial services, they're after security and ease of use. So what does specifically does Radix do with using blockchain exactly? Is it all of the above in terms of verification, security, smart contracts? But is there anything else that it uses that we haven't touched upon yet? And I feel you've kind of half answered this question already.
Sure. Yeah. So it offers most of the above. Our roadmap is essentially a continual deployment process. So we start off with the simple features first, and then we roll out more complicated features over time. The first features that will be on Radix will be very simple ones, and we want to make them as simple as possible because we think that building on DLTs and building on blockchains is a bit complicated at the moment. So our processes for the simple applications on the ledger are API driven rather than smart contract driven. So if you want to create a token on Radix, it's an API call. If you want to do a multi-sig on Radix, it's an API call. If you want to do a structured transaction or a time lock transaction, it's an API call. And so what we've done is we've made a very long list of features that previously on other DLTs would require smart contracts. But we've just gone, well, let's get rid of that. It's really expensive, it's difficult to manage, and there's a lot of security vulnerabilities in that. Let's take that pain out of the way, and let's make it really easy for developers to be able to build on top of infrastructure by providing these tool sets that you can just call directly against the ledger. And so that's one of the sort of core differentiators of Radix and building on Radix. Further down the line, we also have the ability to do smart contracts and things like that, but we think that there's a lot of utility that can be just garnered by providing these easy to use tool sets to allow people to do things that they want to do already, like generating tokens, be that asset-backed tokens or fiat-backed tokens, or being that, Piers token or cheese token, and then being able to secure those with, simple multi-sig and things like that. And that offers, maybe 70% of the utility that you're currently seeing in the market today anyway.
Mm. How does Radix benefit from using blockchain technology in its practices that it wouldn't for any other technology?
Well, we don't use blockchain, but how does,
technically speaking,
how does Radix benefit from using blockchain technology versus any other technology? That's a very interesting question. The answer right now is that it's the technology is not there yet for any of these ledgers. Like, it's getting there, but it's like working in the internet, in the early days of the internet, where everything was a bit janky and a bit technical and a bit difficult to use, and you only really got diehards using it because they believed in where the technology was going to go. They believed in what the promise of the technology was. We use Radix internally for very, very little things at the moment. We are in the process of what I call dog fooding, which I'm sure you've heard as a term, dog fooding more of the internal processes on Radix, because we think that's a really good exercise of working out what the problems that you come across when building on the technology, when using the technology, all that kind of stuff. But yeah, still very early days, and still very, very little that is actually a process improvement for everyday business for us. For other people and projects that are building on top of Radix who have specific use cases to do with immutable data entry and being able to do retrieval of that from anywhere in the world, who need speed of transactions as part of their USP or their product offering, people who want to be able to do end-to-end peer-to-peer encrypted messages, these are all already being used on Radix on our testnet. So those aren't process improvements for us, but they are process improvements for our project partners who are already building on top of us.
Fantastic. And how can startup businesses that work in software or blockchain or want to implement DLT, how can they benefit from using this, or even blockchain if they're just starting out?
Yeah, so blockchain, DLT, crypto, a lot of the value of it comes from a shared universal data store, a way of transmitting and programming the transmission of value, and new funding mechanisms, right? So for the new funding mechanisms, that's quite well trodden. You've got the ICOs, initial coin offerings, and now you've got the STOs that are coming along, secure token offerings, security token offerings. And these new fundraising tools are like really neat for crowdfunding. So often a great way of raising money for your business, although there are quite a few regulatory pitfalls that fall in there as well. From the point of view of a universal data store, this ledger that everyone is maintaining and everyone can access, but you can encrypt and then choose who can unencrypt things on the ledger, has massive ramifications for everything from supply chain management to IoT, to anything that you want to have a shared database, but you don't want one person or one entity to be in control of the server that's responsible for that. You want a much more granular permission set, and you want a much more democratized way of enabling people to access that data and be able to update entries on it. It's an incredibly useful tool for that, which creates, great cost savings in audit and great and greater security in things like how IoT infrastructure is rolled out and things like that, which is really exciting. And then the third thing is sort of being able to program money. So like any time where you, instead of just I want to send a transaction to you, but I want to send a transaction to you and I want it to be conditional on something, right? So I'm like, okay, send this money to this person on the condition that the XYZ is matched. that conditional statements that you can make around the transaction of value suddenly sits directly in the same technology stack that everything else that you're building does, rather than it being within the banking technology stack, which makes it much more flexible and makes it much more interesting to build things like marketplaces, to build things like communities. Actually, sorry, there is one more thing on top of that. So the three I mentioned plus tokenization of non-financial instruments. So often referred to things like non-fungible tokens, so things like CryptoKitties, the idea of digital collectibles. I think it is going to be a huge motivator in the DLT space, and a good reason for any business to think about getting into generating tokens for their communities, because with tokens you can create recognition and empowerment and provide value in the time that people put into something and invest in something, and not necessarily is related directly to a monetary incentive, but can be built around these new types of tokens that people can own and transfer between themselves, which again is sort of massively exciting, and another good reason for businesses to look at tokens.
Sure. You've spoken a little on like amid developments that are arising, but what's next for Radix?
So next for Radix is the launch of our betanet. We currently have our alphanet live, and that's available for anyone to go and play around with our APIs on. The betanet will be live in Q1 next year. And we'll give people the ability to test what our go live feature set is going to be, and start being able to do things like create their own tokens and create asset-backed tokens and do multi-sig and try out our open source wallets and all that kind of stuff. So it's going to be, it's just building on the sort of the small feature set that we already have available, and then making it more scalable and letting people sort of try it in an environment that's going to be more akin to when we go live.
Fantastic. And to people who are watching this, what advice would you give for people who want to use blockchain/DLT, or want to get into blockchain or even Bitcoin or crypto?
I'd say if you're a developer, start playing with it first. Like see what people are doing already as projects, and start like getting really involved in the nitty-gritty of it, because it involves changing the way that you view things. You no longer have like sort of the server architecture that you had before. You now have this decentralized ledger system, that you have sort of inconsistent connections with nodes, and that the way that you push information into it and collect information from it changes, and the way that you think about building your products change. So like play with it for a bit, buy a few tokens, and like try using them. Like just get used to what the glitches are and what the problems are and what's cool about it and what's different about it. For people who aren't developers, I'd say go and read up on business models that are like your business but have specifically got a tokenized aspect to it. So if you're in mobile game development, have a look at mobile games that are integrating DLT. If you're in logistics, have a look at logistics companies that are implementing DLT and blockchain. I think in almost every industry there is already an example of someone trying to do something in that industry with tokens and business models. So go find them, because everyone's writing white papers, and those white papers take you through everything from how the token is going to be issued, to the funding structure, to what the excuse me, what the utility of the tokens are going to be. And that is a great way of getting started and understanding, okay, so I'm excited about DLT and blockchain. Now, how does that apply to my industry? Let's go read some companies that are already trying some stuff in the space, and see if I, as a business, as an entrepreneur, as a CEO, whatever it happens to be, whether I think this makes sense or if this doesn't make sense. Because there's plenty of stuff out there that makes no sense, that has no underlying business value. So you need to go find and see if your industry is ready, if it's something that you want to start going down the route of. Like a lot of people say, it's an easy way of raising money. It's not. an easy way of raising money. It's actually a really complicated way of raising money. It's just complicated on the back end rather than the front end. And you need to dive into that and find out a bit more. If you're just thinking about this from the point of view of, I want to raise some money, then this isn't for you. But if you can see a real place that this might have for crypto or tokens or DLT in your business that solves a real customer need, then yeah, absolutely dive right in.
Is there anything else you wish to add before we wrap this up?
So our alphanet is already live. If you go to radixdlt.com/developers, you can get started there. We've got some wallets, we've got some APIs for you to start playing with. If you're interested in being a node runner, if you go to radixdlt.com/noderunners, you can sign up to be one of our node runners, and soon you'll have the ability to download the node runner clients and start running it on our testnets. And if you're just interested in staying up to date with Radix, if you just go to radixdlt.com and click register interest, then you can sign up and get weekly or bi-weekly updates about the status of the project.
Fine. And also, is that where people can find you if they wish to get in touch with you as well?
Yeah, so on our homepage, there's a get in touch with us button. If you just click that, then that comes straight through to one of our team members, and they'll pass that across to me if you're specifically wanting to get in touch with me.
Piers Ridyard from Radix, thank you for your time today. That was very informative.